Okay, so this topic, 1.3 limits. We want to see what is the definition of the limits. Okay, we do an example. Okay, let's just look at this example. This is my function f of x. I want to find the limit of my function when x getting close to 4 from right side. 4 plus means from right side. I want to see when the x getting close to 4 from higher value of the 4. What is the y value? F of x means y value. Okay, look at my graph. The x4 is located here. This is 4. Higher value 4 plus means you're getting close to the 4 from higher value or right side. So you have to look at this side of the graph. This side of the graph. If the x getting close to 4, what does the y getting close? Getting close to this point, right? What is the y value of that? It's -2. So the answer is -2. Now I want to find the limit of function x getting close to 4 from the lower value. So again, this is a 4 from the lower values. It's from left side here. I have to look at this part of my graph. So I get x get close to 4, the y get close again to -2. If the limit from the right and the left, they are the same, we say the limit of the function exists x when x go to 4 exists, and it's equal to the value. The value is -2. Now, what is f of 4? F of 4 means what is the value of the function when the x is 4? Of course, this is that point exactly, which is -2. It's good to note, as you see, this function is continuous at 4. Means the limit exists, and the limit is the same as the value of the function. This definition coming later, but it's good to note here. Let's just do another example for you to see better. This is other function. Okay, I want to see what is the limit. What is the limit of this function f of x when x go to 3 from positive side? And I say positive side, the 3 is here, means you're getting close to 3 from higher value. If you're going to x go to 3 from higher value, what is the y value getting to? So I have to look at this part of the graph, because this part of graph is for higher value of 3, right? So I followed that. I x get close to 3, the y get close to what? Here, -1. Now I want to see what is the limit of function when x getting close to 3 from negative value. Okay, for negative value means you get it, x getting close to 3 from left side or lower value. So you have to look at this graph, this side, the left side of your graph. So the x, you have to follow that. The x getting close to 3, the y getting close to what's value? -2, getting close to this point. Y is -2. As you see, the limit from right and left are not the same. That's why if you want to say what is the limit of your function when the x go to 3, the limit not exist. The limit is not the same from right and left, but the limit does not exist. Now, what is the value of the function when x is 3? So I have to look at this point. See, this point is empty. When the x is 3, I don't look at that. I look at the field circle. Is equal to -2. As you see, if the function is not the same as the limit, your graph is discontinuous. See, this is when you want to draw that, you have to lift your hand from the paper, come here and draw it. So this function is discontinuous, is a jumped discontinuity. If the limit is not exist, the limit of right and left are not the same, we have jumped discontinuity. Okay. So this is the worksheet that you have. You need to do this. This is the definition. Limit exists if the following criteria is met. Limit from right and limit from the left exist, and limit from the right and left are the same. If this criteria exists, the limit from right and left exists, means the limit exists, and we have limit. Otherwise, we do not have limit. The continuity, if the f at the your function at that point is defined, and limit is exists, and the limit and the value of the function are the same, then your function is continuous. And I'm gonna just do one of these questions. State the limit of the each sequence. See, this is 1, -1, 1, -1. At the infinity, if you continue forever, we don't know at the end what we get in 1 or -1. That's why the limit not exist. For part B, 5.9, 5.99, this is going toward 6, right? But the limit of this function at infinity is equal to 6. So you have to do the rest for me. Question number 1. Question number 2, you have to tell me what's the limit. For example, this is going toward 4. The limit here is 4. Question number 2, A, B, and C you do. Question 3, 4, 5, 6, 7, 8. Pretty much all of these questions is worth of doing, and you should do that.